Good morning, everyone. I'm Tani Jem, and welcome to the first creator track of day 2 of AWE. Hope everyone's having a good time. I am personally working on a project that's called Pencil that teaches you how to draw in mixed reality. And so I'm going to go over a little bit of housekeeping first, and then I'm going to introduce our guests for the first talk. So first off, there is an app that is called Attendee Mobile. It's teal with a little yellow icon on there. You can find all kinds of events and speakers on there so you can start planning out your day. Accessibility notice. Today we have captioning is provided by X-Ray, and this is available on xray.glass/AWE. And for today's special menu of events, we have Learn from the Past to Build XR's Future. Visit the XR History Museum and in the exhibit hall and check out the XR Walk of Stars powered by Snap Web AR. And that's outside if you see little stars on the ground. Also, in the expo hall, we make sure to visit the new expo stage for more great content and connections. And there are more playground experiences than ever before at any AWE, so be sure to go check those out. We have the startup pitch competition today that is from 2 to 4:30 in room 103C, which I believe is our neighbor. And we have the 15th annual Augie Awards and XR Hall of Fame ceremony. This is from 6 to 7:30 p.m. in the Grand Ballroom, the main stage. Food is available for purchase at the venue outside there, and at many restaurants all around in walking distance. Social, we have the AWE team encourages you to post through your social media channels and use the hashtag AWE2024. Recording and sessions. A reminder that the main stage sessions are live streamed and added to YouTube. Track sessions, like here, the creator track, will be recorded and will be made available online on YouTube approximately a week after the event. The Wi-Fi is AWE_Wi-Fi, and the password is Spatial, all one word underscored, or under lowercase. All right. We have some sponsor appreciation. The AWE team would like to extend a huge thank you to our diamond sponsor, Qualcomm, for their support. We'd also like to extend a great thank you to our titanium sponsors, Meta, Niantic, Snap AR, and Sightful, and of course, our gold sponsors, AWS, HoloLight, Infinite Rabbit Holes, Lenovo, Magic Leap, Microsoft Mesh, Nipa, Pico, Xreal, and Zappar. And finally, we extend our gratitude to all of our sponsors and exhibitors for making AWE a reality. So, right now, this panel is 3D content creation for spatial computing, in which we're going to learn about these standards, like making some open source standards for content creation, such as 3D objects and making them like easier to download and just like having some good standards so it's all friendly across all of your platforms. And I'm going to be introducing Alexey Medvedev, who is the AR tech lead at Meta, and he's going to be leading the panel. So happy day, everyone.
Thank you very much. Yeah, my name is Alexey Medvedev. I'm working at Meta in AR Glasses department, and meantime, I'm the chair of Khronos 3D formats working group. We are working on glTF spec, KTX, textures, and Collada. And today there will be a session about what the glTF is and how we help to create the content for 3D, for spatial computing. So basically, if you don't know, the Khronos organization, we're working on the open standards for the GPU and the compute, etc., etc. It's completely open, and we've seen the necessity for the similar spec for the actual 3D content, so how the glTF was born. And nowadays, we see growing market for spatial computing, and we understand that glTF in the base form was not enough to represent all the complexity for this new future, and we decided to extend it, and it's an ongoing process. So we kind of evolve this spec as for today. We'll present what is going on, again, to be more friendly for this new 3D world. Let me introduce and start with the introduction, our presenters. And let's start with Peter. Please introduce yourself.
Hello, I'm Peter Martin. I work as a software engineer at Adobe. I've been there for the past 2.5 years, specializing in 3D applications and especially with XR. Before that, I come from a background of some doing visual effects as well and virtual reality applications. And I've been working with the Khronos group a lot recently as it deals with interactivity and glTF especially.
Olga?
Hi everyone, my name is Olga Dogadkina and I'm the co-founder and CEO of Imperia. We are an immersive commerce platform and we work with large enterprises within retail, entertainment, as well as studios and 3D creators to help them deploy immersive experiences on the web and across XR devices as well. And we've been in this world for the last 5 years, and before that my background is predominantly within fashion and retail.
Leonard?
Leonard, Daly, independent systems consultant, and I'm working consulting to Khronos, managing projects on their 3D formats, 3D commerce, that's glTF, and 3D commerce, the panel was yesterday. Also working with the OpenXR group, all to develop projects that expand the use of their specifications within their communities.
Thank you. And we can start with the actual discussion. So we see that we are transforming the paradigm that we create like a 3D experiences to be from the custom coding. So that means you have to write your own code to be like more friendly and data-oriented approach. And we want to see how we can build these complex interactive scenes and reuse 3D assets as much as possible. And especially if we can use the different sources of data, not created only by one particular provider. Olga, that's a question for you. What will such experience looks like and what file formats we'll use in this case? Because, yeah, you're presenting our client's point of view.
Yeah, absolutely. I think, and also if you maybe click on that slide, it should play the video.
Yes.
So what you can see on the screen is a quick reel from the Walmart Realm experience we've launched recently on Imperia platform. And the way that we would usually look at user experience and creating for virtual worlds and the assets within this as well is what is the core purpose of the target and audience and the user. And that's where the UX really is going is about cross-device interoperability, because what we're currently seeing is there's no longer kind of a state of experience where we're deploying separately for mobile and separately for VR and separately for Quest and Vision Pro, and all those things are becoming so complex. And what the consumers are actually more adapt for is the experience that is universal, regardless of whichever device that they're accessing it from. So when we're building for those experiences, whether they're commerce-driven or even just entertainment, training, whatever is the purpose of that experience, what becomes super, super important is how it can be deployed across multiple ecosystems and accessed from the easiest point of access, where we no longer need to download things and wait for stuff to set up our accounts and profiles and all those types of things, which just create barriers to entering XR experiences, which for majority of consumers are still a novelty, even though we probably within this room and this group have definitely been talking about this for years. It is still something that is kind of crossing the chasm with general consumers. So that's where when we're crafting the experience and using the formats to do this, the lightweight and interoperable becomes the very, very core focus. So when we build the experience, we would typically look at formats like glTF and glB. So we would usually build environments within Unreal Engine or any other platform which allows you to deploy the environment, and then layer that interactive layer that can be deployed across different platforms and look consistent regardless what device you're accessing it from, and load within a few seconds. So that's the very core of UX for us.
Thank you. And as the continuation of this question, what do you think is important for transition, like to be more like reusable for the assets in general, and what kind of new possibilities it unlocks for the customers and for you?
I think in terms of transitions, and if you maybe switch to the next slide, what's really, really important, what you can see here is the AR deployment of well, in this particular case, the furniture models and how they look in the real world. And what becomes super important with assets is, first of all, consistency of the asset format that can be carried through from a platform to a platform. Perhaps physics as well, which I know Leonard is going to touch on in a little bit too. So how we work with light, how we work with light in different environments, whether virtual or physical environments as well. And also the quality of those assets, because one of the biggest pieces, particularly with commercial applications, is realism, and that's where when we work with large enterprises and deploy things for retail, it becomes super, super important that things reflect what they are in the physical world, in the real world. And so by bringing that standardization, that's where we can achieve it across wherever it is that the user is accessing it from.
Great, thank you. Why do you think it's so difficult to create such of experiences?
I think the main premise of this is that every asset has to follow the same specification, and also we really need to focus on the quality of both asset creation and asset components putting them together. And the main thing, so what you're seeing right now, that's also actually a video. That is a quick recording from Apple Vision Pro with a virtual showroom. So transporting, there we go, cool. So transporting the asset from one device to another while maintaining the quality is a very big challenge. So what we've been working a lot with at Imperia is how do we create a pipeline where we render from one single place, and then wherever it is deployed, it looks consistent, looks the same. And that's becoming even more so the consistency between the Apple Vision Pro, Quest 3, and the web devices, essentially. So I think that's why it's really, really hard to keep the quality and maintain the kind of high fidelity of the experience while also enabling it to load really fast, essentially.
Thank you. Let's switch over to a slightly different topic. And for example, if we have the different objects from different diverse sources, we need to create some sort of environment that the objects should coexist in the one single scene together. And basically, we want to build the rules on top of this to define how those objects should interact. And that's a question to you, Peter. You're working on the new interactivity extension in our working group, and animation pointer, which unblocks a lot of complexity and a lot of freedom, actually, how you address the glTF properties, etc., etc. Please walk us through how the draft interactivity spec works and what we're thinking about when we design it.
Right, yeah. So when it comes to interactivity, you've long been able to sort of create interactive experience with 3D assets. I mean, you can go into game engines, of course, but for the lighter use case on the web, you can think Babylon, 3JS, Model Viewer. All of these allow for like some low-level custom code and custom input for some level of interactivity. But if you want this to scale at all, if you want to view third-party content, and if you want to have a third-party viewer view other content created and authored by other engines, right, it's important to actually standardize interactivity and have it all in one place. So the point here is that if you look at the slide here, you can see that a typical static glTF asset with this interactivity extension, all of a sudden you have some sort of product configurator use case here that should work embedded in a lot of different workflows. When we were first thinking about this, there was a few different workflows we were thinking of for how this could be designed. Originally, we were thinking of some sort of trigger action workflow where it's like on tap, wait a few seconds, spin this asset, rotate this asset, play this animation, kind of like a logic chain. But we decided to handle a more complicated use case and actually allow for the glTF to embed direct node logic graph inside of it. So if you're familiar with Unreal blueprints at all, it would be something similar to that kind of style. There's a lot of different sort of logic style of node graphs handled. And of course, the idea is you might not have to worry about that. You probably won't have to worry about that at a higher level authoring case for what's going on, but that's what's going to be serialized at the low level is all the logic. And so this is actually Turing complete, which means that you can kind of create basically almost whatever you can think of using these kind of node logic graph stuff. And if you're worried about security implications with that, keep in mind this is file format, so there's no file system access, there's no network access, we're not thinking of the multi-user case. And one thing that we went further with for this node logic graph is the idea of not allowing dynamic allocation of new memory, so no arrays, no strings. If you know what that means, that's great. If you don't know what that means, that just means more security. With that, we're leveraging something called the animation pointer extension, which basically inside a glTF asset, traditionally animations are kind of more for handling transformation cases. And with this animation pointer asset, you can point to any other part of the glTF and animate that property. So you can animate materials easier. You can transition those. And using that with this interactivity extension, you can then basically animate whatever inside of the glTF you want on interactivity. You want to switch to the next page. This is like low level what's going on. Again, low level, if this scares you, then don't worry about it. There's going to be higher level interfaces to do stuff like this. If this doesn't scare you, talk to me after. I'm really interested in what you're going to come up with this sort of stuff. But again, the idea is all of this will be serialized directly inside of the glTF for standards, so your content that you make interactive in one system can go into another system. And all of this is part of the general thesis of making glTF assets more like objects, where they have some level of properties innate with them that can go through any different platform with that. And with that, Alexey, actually, I believe you have been adding, working on another extension that extends off of that thesis of abstracting away other properties, like adding physics to glTF. Can you talk more about that?
Yeah, sure, absolutely. Actually, if you check the evolution of glTF assets as for today, we kind of moving out of the representation glTF content as only 3D model, geometry plus textures and plus some necessary information like materials, to go into the way that we actually are starting to represent the actual virtual object. And we want to express and expose different properties of this object. Along the way, you can control this by interactivity, but the next natural step actually is to express the physical properties. And that's why we are working on two extensions, KHR rigid body and KHR collision shapes. We split those for obvious reason sometimes. First of all, our approach is to be the engine. It's a spec, it's not the implementation, it's not runtime. We want to be physics engine agnostic. That means we express only properties. And it's up to the client, code, or viewers to decide how to use this. And for the collisions, you can, as you see on this the picture with the yellow chair, basically we express how exactly the collision shapes looks like. We support some pre-baked shapes such as spheres and cubes, etc. And you can provide the arbitrary convex mesh, convex hole mesh, that allows you to interact with the interactivity spec and build like such complex scenario when you can hit the particular mesh shape, do some reactions on top of this. It's for the favor to be more compute efficient. So we kind of extremely low level efficient format. Another extension is rigid body that allows you to describe the physical properties of the objects and like mass, the friction, etc., you name it. It's super friendly for the current existing physical engines that we have on market. It can be easily translated, and that means you don't need to put a lot of complexity into your asset. For example, the way how you can mimic the actual real life, it's just like you can create the animation for the object, it will start to behave like fall down or something that reflects how you perceive the objects in real life, but physics engine actually unblocks this, not necessary to do any pre-compute for this. It can be naturally simulated on your device. And important point, again, it works in conjunction to everything else in the glTF ecosystem. So you can add the physical properties, you can interact with them, you can build really complex scenes, and actually this is our next topic. We definitely want to expose this flexibility for the people. So nowadays we're talking about one single glTF that embeds all the properties inside it. So the next logical question, what if we want to create the actual world? And that's why we work on the complex scenes. And Leonard, he's working on this direction for our group. And that's the question for you, Leonard. What are the challenges and considerations associated with the bringing 3D assets from the different sources together into complex scenes? What kind of formats we're using, and how we build this?
Thank you. So this work is right now in prototype stage. We're just starting on it. We have not written any specifications yet. Even though there's some documents online, they're not meant to be taken literally. There was the initial proposal, and this is then the work that's been developed from those initial proposals, sometimes finding that we had to make significant changes. So the first case that we had to look at was lighting. So it's a question of whether the light is off. If there's a light on one model and you bring in two models into the scene, is the light off entirely? Is it just illuminate the one model it's attached to? Or does it illuminate everything like you'd see right now? Is that really playing?
I believe it's played. Right?
Okay,
So we need to-
but now, so that's a single model light. That's a light everything in the scene, and then the last case, or the first case, is light nothing. So we've come up with means for being able to express that option, and of course, if you have a much more complex scene with multiple buildings that you want to only light up a few of them, then you can group those. The way it's looking at now is going to be a new file in addition to glTF that contains these information about how to assemble the scenes and how to control things between elements of the scene. Next one. Next one was level of detail. And this is really important because we can easily construct models that are way too big to download to phones and have them run there. So we had to consider not only the device that you're using, but the network that it's on, and also just general, do you really need to pass 50 megabytes down to a browser when somebody just wants to get an overview of what the model is? This case, and run the video, please. They found several different means for controlling it, whether it's based on a percentage of the display, percentage of the model displayed on the screen, how much of the screen space it takes up, or the distance to the model. There's other considerations too, and we've cataloged all those options and included them so that they can be used. It still needs a little bit further explanation and careful writing of the specification for that part. Next.
Next slide.
Yeah.
Mm-hmm. Oops.
Okay, so this one, and we can run the video. This one is billboards. This has been asked about since glTF dropped billboards in 2017. There were some security reasons for doing so. This is our bringing them back. And this ends up as an extension to glTF, so it's not in the additional file and can be included in the larger cases or just in individual models. This illustrates several different billboard styles. One is attached to objects and is always in front. One is attached to an object and is further behind, or just floats wherever it needs to be. And you can see then, we're going back to the side here. So some are just invisible and not even rotated towards the viewer. The scene concludes with these trees that are also done as billboards. So it provides a nice means for doing things where you don't need super detail, but you need enough detail that it doesn't look like it's completely fake. Next. This one shows the overall collection of scenes. This is the chessboard is one model. Each chess piece is its own separate model. They've been put together, but the models will be attached and parented, so you can move any of the parents of a model. In this case, run the video, please. In this case, the table moves with the chessboard and pieces, and at a later stage, the chessboard will move by itself. So this work is ongoing. We expect to start working on the details of specification sometime this summer. It'll take several months to work that out. We're looking forward to contributions. Everything is open source and on the GitHub repos. At this stage, we just have the initial concept explainers, but there'll be more detail coming later. So now that we have these capabilities, we go back to our UX and see what things are really needed and how does everything get put together. Olga?
I think the main thing when we think about the pipeline of asset creation for whether it's a complex scene or a single asset is, with this use case, what exactly we're trying to achieve, and are we going into a more game-style model, like a Roblox-style model, or hyper-realistic quality? And one of the great things with glTF, and the same with GLB as well, is our ability to make the model looking hyper-realistic, even though it is still quite lightweight and pretty optimized. And I think that's where we're building this pipeline. I think what this slide is also probably skipped one question, but we can go back to that. But yeah, in terms of the pipeline of the asset creation itself, I think what's super important to think about is the PBR materials and how the material gets applied to that geometry once it's optimized for the different devices where it's displayed. And that's where the LODs and those considerations really come into that pipeline, and the team setup, whether we're going from individual modelers and texture creators, or all of that is being done within kind of one continuous process.
Speaking of the content creation back again, so how do you think the textural realism is important for glTF and for your specific use cases?
I think especially for our use case is extremely important, because that's where, again, we're really looking at physical products present in digital worlds and digital realms, whether it is within a world context or even on a single web page and in a viewer. So that's where what we can achieve with the texture is often able to mask up what we can't achieve with geometry or can't publish with the geometry. It's a bit simpler in the world context because the limitations on the geometry is a lot less. But in a viewer context, that's where the realism of textures can very often, like, we can take an object that is literally, like, it looks like nothing, apply a great texture, and it will look like a great realistic object. So the very, very big focus on textures and libraries in the materials where those materials are stored. So we would very often use materials from Quixels and Megascans, or even create the materials from scratch. So that's where the textures become kind of at the forefront of what the asset looks like in the end.
Great, thank you. Maybe let's change our topic a little bit and let's discuss the best practices and collaboration. So I assume the creation such of complex experiences is not trivial job, and basically you need to somehow assume that's multiple people working on the assets at the same time. So Olga, you're probably the most kind of valued customer for us. Can you please do some recommendation for the people how we operate on this level?
Yeah, of course. And I think that's where the way we operate is, it's about enabling people to both do their best work, but also we really believe in enabling 3D artists to be generalists in a sense and do everything in the scene from asset creation to lighting. But at the same time, creation of experiences like this, and yeah, that video is a recording from our Hugo Boss experience, which is one of the most hyper-realistic scenes, I think, that we launched. And of course, it involves multiple people that are very frequently spread across multiple geographies. And this is where it really comes down to two things: the team structure and how the team operates together, and also the guardrails and boundaries that we set up for each individual project, which again goes very much from what are we trying to achieve with this, and limitations that not necessarily limit the creative process, but more set up its boundaries and actually help by taking some of the thinking of, what's the poly count that we're going with, or what are the formats that we're using, or what are the libraries that we're accessing to actually build this. So by creating this unified language within the team, we can really drive the consistent shared outcome, where on that specific scene we had maybe 6, 7 people working simultaneously, but the outcome looks really, really consistent. So that's not to say that one artist can't do the full process from kind of beginning ideation all the way to publishing. They absolutely can, and we do within our creator community. We do have those cases where it would be a single freelance artist doing the full flow, but the team operation dynamics brings a level of complexity, but also a level of artistic perfection into it.
How you can encourage people to stick to some sort of best practices when you organize the work for them?
So what we would usually do is we would set up the kind of guidelines for the project. And I think what's really important is not just kind of be like, okay, here's the guideline, go ahead and use it. No one's going to want to do that. It's bringing this shared belief into the team as to why this is important. So when they choose a certain format, there's a true understanding like, yeah, this is going to be the best for this particular purpose for this particular commercial application that we're doing as well. And something that we really encourage, particularly with remote 3D teams communication, remote 3D structures, is super open communication between the art leads, the artists, the technical lead, all the people that are involved in this pipeline, because in the end, it's really about the shared outcome. So by building this into the process where we would start with the kind of overall setup for, and our projects are pretty consistent, but that's how we would approach pretty much any type of XR creation, where you would go from, yeah, these are the methodologies and the libraries that we're going to use, and these are the team members and how we're going to use them, and that's the kind of communication style that we embed underneath all of it.
Thank you. Oops. I have questions to all our panelists. First one, what are some of the emerging trends or technologies in 3D content creation that you find more exciting, especially regarding physical simulation and real-world interactions? Peter.
Yeah, I think I'm excited for a lot of different use cases that people can do, especially with XR. I think that the idea of having standards for these things and just being able to exist in a shared space where they can go into one common ecosystem is really cool. So thinking of specific examples, it's just to think that you could have some sort of embedded adventure experience that's just one complex glTF asset scene, and that could go into any different viewer or experience, and you could just play that back. I think that it would just be really cool in general.
Thank you. Leonard?
So I'm looking forward to seeing full work with digital twins. That's a really large area that we look now with interactivity in physics and complex scenes we should be able to fully address within glTF. Also along those lines, not taking all those technologies, is being able to support the fashion industry. Hair and fur may be a little ways off, but clothing looks to be now doable, which was not doable just 2 years ago.
Olga, do you have any thoughts?
Yeah, on fashion, yeah, definitely that's a very exciting advancement, I think, when it comes to clothing and cloth simulation in particular, and the opportunities that it brings down the line into virtual try-on as well, because that's something that's super limited today to in-app only applications, and as we're seeing it and the web applications, I think that's super exciting. The other thing I'm excited about is the efficiency that this is bringing, because as we're thinking about unified 3D formats and transferable assets as well, this means that, well, we have to spend less effort, less time, less money to actually deploy these experiences so the true scalability can be achieved, which has been a challenge for a long, long time.
I probably can speak for myself in this case. I'm really impressed by several directions we're doing this here in 3D formats. First of all, actually it's interoperability, that we are not touched today too much, but I want to mention this. We are working closely with AO-USD to make the glTF and USD friendly to each other. That means we will complement and express the best parts of USD and best part of glTF for the customers, again, to make their life easier. It's really impressive multi-company, multi-org project that happens today. I'm really glad it's going, so that's number one. And we have a really decent set of the extensions. As you can see, our roadmap, we will release this year. The new audio format we are working on, which again was not topic for today, but yes, it's happening. And we have plenty of new PBR material extensions coming in as well. That means we will get the more flexibility to express the different complex materials using the same, in my opinion, amazing glTF approach when you describe only material properties and not dictate any actual implementation for it. And obviously interactivity and everything connected to interactivity. That's super impressive. It's a dramatic change from the representation of glTF assets to this kind of new world. And I have one more question. How can those here today stay up to date on the evolution of the standards we discussed today, or even influence their future this direction? So basically, what's next? What do you think should be next for us as the glTF that we not cover here?
So working on external references or complex scenes, I'm already out about a year on this. Looking at what's next is we're seeing some things in the complex areas that may not be doable immediately, so we'd be pushing those off, but it's too nebulous to say anything. If you're looking at outside technologies and comparisons, what you just mentioned with the integration with USD is a 2 to 3 year effort based on when USD anticipates releasing their specifications. And that's a big piece, and then developing all the test cases and suites to support all that is a major amount of work and has about that timeline of things. It's not new technologies, but it now assures that people have a means to test that all their conversion and integration, development, exporters, importers all work together correctly.
Olga?
Oh gosh, I feel so much has been covered in terms of where we're going with glTF. I think the main thing in terms of staying up to date and contributing to this is I feel this particular industry is probably one of the most community-driven type of technologies that we're looking into. So realistically, it's the contribution into all of those topics that we probably covered in here. Peter, you're like in the challenge
What
now.
you impressed for the future?
Yeah, I think as Olga was saying, it's a very community-driven effort. There's a lot of open source stuff. You can give feedbacks on all the stuff that's going on with the Khronos group that's open source, and that is kind of where we're going to see most of the future. I'm most impressed by just like the increasing way in which we're standardized more complex things. And that is what I'm most excited for the future. Because if you just like think about where the web used to be just like 10 years ago, where you needed all these proprietary players in order to do just about anything, and now it all works natively on device. And I think that if we could get 3D to work the same way, that would be just exceptional.
Great, thank you. So we have some really minor housekeeping stuff here, so that's credits, licenses, etc. And we have about 15 minutes for Q&A. So if you have questions, please go ahead.
And wait for the person with the mic to come by so that we can all get these recorded.
Test, test. Are we good? Yeah. All right. Hello. Hey, Tony.
Hey everyone, Tony Parisi, one of the original creators of glTF. This is a really proud moment for me, guys, and I haven't met all of you in person yet, but I have online. Wow, I am so impressed by where you've taken the spec the last 3 or 4 years. I was off doing other stuff, and I think that's a testament to the resilience of process and an approach like we've been doing all these years. And so that's flowers for all of you, amazing. I do have a legit question after hearing all of this. All of these new initiatives are incredibly complex. The interactivity stuff Peter's working on, the complex scenes, all the new rendering, everything. Love it. The team talked me out of doing a bunch of that stuff 10 years ago when we were getting going, saying it's never going to hit the market. No one's going to adopt it. It's too complicated. Let's not do that. Let's just do models, animations, keep it simple. So here we are embarking on a new world where you want to take it forward and make it really complex for all these really good reasons. So the question is, how are we going to manage it? And it's a technical question, maybe, Alexey, maybe it's a process question,
yeah,
Leonard, et cetera.
Okay.
How is this going to actually get done?
That's a great question. I probably can start and then, yeah. First of all, yes, it's some sort of technical question as well. We are trying to be prepared. So we built in some software that help us along the way. It's literally like a different set of tools, like validation, certification, sort of referencing tools, the test suite, and it's planned. It's it's extremely ambitious, but yes, we kind of considering this. It's a boring part. Probably the other guys, they'll just say something more fun than me. But yeah, I mean, it's a complex problem. We kind of trying to be mindful about this.
Yeah, well, I'll say something. I think that the way that glTF is designed, where a lot of it's based off of extensions, is key here. Because obviously not everything is going to support every extension all at once, right? And as more features get added, there's more extensions. And so with some of the interactivity stuff I was talking about earlier, right? Like Babylon.js, a web-based viewer for 3D assets, already allows you to specify some level of interactivity inside of it. And the idea is we're working with these sort of viewers and whatnot so that these big viewers first can kind of work to use these extensions. And as it's used in more, as more viewers are using more extensions, there's more of a market-based desire for other viewers to also be like, oh, now we need to support that extension because this person's doing it. So it's a slow process there, but that is our goal. I'm not going to speak to anyone's roadmap in particular. I'm not there to do that, but that is our goal, is to get different viewers of different sorts to support these first, and then there's more of a market demand for everyone else to do that.
So, excuse me, the one overriding concern we've had in the philosophy of all this is don't break the ecosystem. It's really important that everything that currently works stays working. That means these new features that we're adding are either extensions such as interactivity or physics, or in the case of glTFX, which is a complex designation, those are too big to fit into glTF, so we took those and created a whole new separate file format. If your viewer doesn't support that format, you don't have that feature. But glTF, as before, did work, and some of the things that we found, like Billboard, will be able to be as extensions into glTF. So we're not breaking the ecosystem. And as far as helping the community along, Khronos has been producing a number of different videos on these topics, some very technical, relating to materials and appearance. We'll produce, at some point when the time's right, a set of videos on how to do interactivity or how to do complex scenes or whatever the topic is that the community feels they need help in. And so we carefully monitor the community at events like this, at events at SIGGRAPH where we have the ecosystem forum, and throughout the year.
And along the way, we kind of produce the software, again, as I said. So that means if you release new feature, usually implement it at least in several open sourcing projects, for example. We're trying to be friendly. But assume like holistically, yeah, it's an effort for industry actually to adopt those ambitious kind of extensions like interactivity. But meantime, we've seen demand. That's why we started to work on this. We've seen like use cases when the other companies came to us and showing like what they're doing in glTF. And glTF was not designed to do these things, but they kind of start to use because it's a convenient and easy to use tool to do so. And that kind of came naturally.
Thanks for a great presentation. So my question goes in a similar direction as Tony's. So a lot of these new extensions kind of cover accessing and interacting with entire scenes and other extensions. And something I found challenging in the past, for example, when we specified the KHR animation extension, is there's a need that it is going to be able to animate future stuff, right? That it's going to be able to animate future extensions. And similar things happen here with you have payloads and GLXF and so on. So like, can I trigger those from KHR interactivity? And so things suddenly become very complex to a point where, at least to me, it's not super clear, like, what is the expectation for someone then using these features? Because suddenly we're not in the space anymore where your application supports like KHR animation. You can say that, but then new extensions come out. So, and nobody has any understanding of, okay, does support for KHR animation now still mean these new extensions, or does it only mean the stuff that was out before? And I understand this, like you mentioned, it's an industry problem on figuring it out, but I think some of it, I would be curious how the spec is phrasing that. Like there's a difference in like animation or interactivity spec saying there's an expectation if you add new extensions, make them work with this stuff. So that I'm curious about how that is managed.
Peter, want to take this, or I can reply? I can reply, actually, yeah. So first of all, yes, that's a problem that we are aware of. And yes, actually, we produce exactly this wording. So the new extensions that want to cooperate with the interactivity, they should add the sections into the spec describing exactly how interaction should look like. And actually, we are running, the audio would be like a first extension that was designed this way. It's not the part of the interactivity spec, but it's part of the audio spec. And that will be like a template for the future extensions to representing how it's supposed to be implemented. And we cannot enforce it, obviously, for the vendor expansions, but we will take care about all the KHR extensions for the future to coexist with the interactivity. So, yeah.
Yeah, I think one follow-up question there would be, how do applications that support glTF then in the future state their support? Like how I see it, it's going to deviate pretty quickly in like giant matrices.
Yeah.
Can we support this extension with that other one as well?
Alexey, repeat the question.
So basically, the question was how the actual applications should implement all the future possible extensions to cooperate with the interactivity. So not, yeah. Sorry.
Who's next?
Let's see.
Just follow up.
Yeah, just to rephrase. So like one part is how does the spec tell applications to do that, right? The other part is I think there should be some guidelines around how an application states its support for specific features. So because that is something that we run a lot into with creators, like bringing their files all over the place, and it's really hard to find documentation if you like take Substance Stager or something like this. Yes, it supports USD and glTF, but you find nowhere like what exactly does that mean. And I think it would be great if there's more effort from Khronos on also saying you should document your support in this and that way, like make a feature table, make it in this format, make it really clear, so that people understand what is actually supported and what not, because currently it's creating a lot of frustration for people moving between these formats, and then random stuff breaks from their perspective.
Yeah, I think it's enough to document it, right? Because documentation goes out of date, right? It just,
I mean, but that should be on applications, right? On,
I have probably...
we've talked about this. It's like testing. You got to test and automate all these viewers with automated content. Maybe you guys can talk about that, because I think that's super valuable.
Okay, yeah, so basically it's, yeah, let's do this like in two pieces. First one, we're trying to express as the part of the spec, you define some sort of properties that can be addressed by the interactivity. And those properties has the meaning, that means you can read or write, or you have some way to interpret this. So this is pretty much formal way to express what you're saying. That's only part of the story, and probably if we should dictate the actual runtime implementation, because it's a lot of complexity behind this. We kind of discussing this all the time. We have no clear understanding as for today, should we do this or not. Probably there will be, yes, some informal proposals how it should be implemented in the application. The other part that Eric mentioned, actually, yes, we are working on the validation tools that will run those cases. We want to generate really complex scenarios with the interactivity and animation pointer kind of, and we want to create this sample reference implementation for this, at least to make sure they are kind of coexist together. And I assume that's, well, people who's working on the actual code can use this as a reference how to implement this properly. But in general, it's a very complex problem.
Yeah, just to close this out, like I don't think there should be any enforcement on like what features an application needs to support and not. I think it would be great if Khronos has some language around applications supporting glTF should document what they actually mean by that.
Yes, absolutely.
And in a clear way so that someone can point them to it and then say, like, you want to support like glTF, then at least tell people what you are actually supporting there.
I completely agree. I think that's it's a hard problem. I think that at the very least, again, the way that glTF is designed is to be very granular with extensions. And what I'd hope that would mean is that applications supporting glTF would be like, oh, because we're supporting animation but not KHR animation pointer yet because we haven't developed that, that means animations will not support this. I would love to see that as well. At the very least, it does mean that since it's granular and extension-based, there should be an error right away saying, oh, wait, there's actually this part of the representation of the animation can't go into this export without KHR animation pointer.
One of the items that we've been looking at and haven't really managed to get our hands around or brains around is profiles, where if you say you meet a particular profile in your content, that means you're not using anything outside of that capabilities. And if you're a viewer and you say you support a particular profile, that means everything within there is supported. You may support other stuff, but at least that much. That way, then you can move content between viewers and have the expectation that it runs correctly.
Any other questions? We still have 2.5 minutes.
There's one more.
Okay.
Yeah.
Yeah, so we are working with a Gaussian splitting assets, and we're dealing with the other nerve-raised solutions, and there's a lot of community developing those kind of extensions, but the technology is raising too fast, and I find either USD or glTF should, sooner or later, we should follow those kind of directions, which supports AI-generated assets. And what's your plan or idea on this direction?
You kind of already answered this question. So as soon as it will be mature and established, probably it will eventually be a part of glTF. And
so basically, it's premature.
Yeah, if you check what changes in glTF since we defined the core spec, the answer is nothing, right? So that means it stayed for years and like decades, and that's the goal for glTF. Yeah.
If we have time for one more question, 2 more questions.
Yeah, that was a question.
So my question is, this has been great tech talk, and I've learned a lot. But give me real-world applications that this might be used for.
Oh, I think that's probably for me. I think what we see the real-world applications, so we work with an immersive commerce space predominantly, so a lot of household names like Walmart, Hugo Boss, Lacoste, Bloomingdale's. And that's where it's very much about how we engage younger audiences, because realistically, the current web channels are getting quite dated for when we're talking about Gen Z, Gen Alpha, and bringing this more realistic, and by realistic, I mean the way we interact with the real world is in 3D, so it only makes sense for the way we interact with the digital world to be in 3D as well. And that's where, when we're looking at commerce, when we're looking at entertainment, the same thing. How do we bring what we do in the physical world, how do we bring this into the digital realm, whether it's currently kind of scaled down to the mobile device, but also the XR devices are getting more and more popular with general consumers. So that's where, when we're looking at commerce, or even, I'm looking at Southwest here, even looking at in-flight entertainment, because I know like Lufthansa just brought Quest 3 into in-flight entertainment suite as well. So some of those things of connecting the dots between the physical and the digital And it gets adopted from all the different areas where people that are using 3D and interacting with 3D now have absolutely no clue how it's created, and that's what it should be like.
And we in time perfectly. So last second, please meet us at the Khronos booth. So we have a booth, and we have stickers here. Please suit yourself. Thank you very much.